Okay, we come back together, and I need to correct this, please. Shh. Okay, as you approach infinity, no way does this equal 0. Do you understand? I don't. The reason is I don't think you can apply L'Hopital's rule, because if this were to go to infinity, you'd get infinity times negative infinity, and you cannot manipulate this to get the right form. Okay. Because you'd have infinity over 0 if I moved it to the bottom. Does that apply? No. So that's my mistake. If you go to infinity, you cannot apply L'Hopital's rule. Another way to look at it is simply, if I go to y equals, you don't have to do this, you can just watch, and I have x to the x. If I go look at my table, well, at 1, well, 0 to 0, by the way, is defined as 1. Do you know that? Yeah, it is. Well, actually, it's undefined. So I don't know why it gave us that. But at 1, it's 1. At 2, it's 4. At 3, it's 27. Because isn't that 3 to the third power? 4 to the fourth, 5 to the fifth. And if you notice, this gets big really, really what? Fast. So there's no way that that limit will go to what? 0. And the error in this is fine. As x approaches 0, it is 1. However, because in fact that's what they did here, but if you look at this one, as it goes to infinity, it equals infinity, not 0. So I apologize for that. That is a mistake, because I cannot apply L'Hopital's rule unless I get what? What are my forms? Infinity over infinity, or what? 0 over 0. Here I had infinity times infinity, and I cannot manipulate that to get one of those forms. So I cannot apply L'Hopital's rule there. Okay? All right. We need to go back and we got a little jumping around to do. Let's go back and do 11. Let's find the area under that curve. I kind of gave you a hint over there. Okay. So would everybody agree we have to find the antiderivative of what function? Tangent of x dx from where to where? 0 to pi over 2. Okay. Now my question is, well, what's the tangent of 0? 0. What's the tangent of pi over 2? Infinite, right? So do we have a place where we have to take a limit of? Yes. Because by the way, do you remember what the tangent graph looks like? It goes up, and we actually get an asymptote at where? Pi over 2. And it's so really, we're starting at a value of 0, and we're getting a certain area. We want to find out, is that finite or not? Okay. So I need to say the limit as b goes to pi over 2 of, from 0 to b, of the tangent of x dx. Now, up on the board, Kevin was really smart at prompting me a minute ago and saying, what is the antiderivative of the tangent? What's the antiderivative of the tangent? It would be the negative. So I'm going to get the limit as b goes to pi over 2. It's the negative natural log of the absolute value of what? Cosine of x. And we need to evaluate that from 0 to where? To b. And this is going to take a little bit of thought. And I know we have to have our thinking caps on here. So this is going to be the limit, and I'm going to make sure I dot my I as b goes to pi over 2 of the negative natural log, the absolute value of what? The cosine of b plus the natural log of the absolute value of the cosine of what? Pi over 2. No, of 0. Okay, let's do the easy one first. Let's start at the right side. What is the cosine of 0? 1. Everybody agree that's 1. What is the natural log? So this is equal to 1. What is the natural log of 1? 0. So does everybody understand? This piece here becomes what? 0. Okay. So this is the cosine of b. As b goes to pi over 2, what is the cosine of b? Is 0, right? Everybody agree it's 0. What is the natural log as you approach 0? What does it go to? Negative infinity, but what's out front here? Negative. So what does this equal? Positive infinity. So does it converge or does it diverge? Diverge. So I want you to think about it. Whenever we've approached a vertical asymptote, what does the area seem to be? Infinite, right? Seems to be infinite, okay? But as we approach a horizontal asymptote, it might be what? Finite or infinite. Could be either one. Okay, what time we got? 25. We're done at what? 40, 43. We won't have 8 bells today. All right.
On the AP test, should we just like always write whether it converges, diverges?
Well, on these, just so you know, these would be multiple choice questions. These most likely would not, if you'd ever see one of these on a free response, it would be one piece of it. But you'd need to show all the work for it. They would expect you to show the work. Okay. But most likely, they'll give you 3 of these and say which ones converge. In fact, that's why you'll see some of those. All right. So we have 2 more. Wait, you know what? Let's go down and do these. Let's go do 20, 21, and 22. Okay. Do these look like a couple of those on the final? Yeah. That you loved so dearly? Okay, we're finding the antiderivatives of these. So what is the antiderivative of 6 to the x power? I'm going to get a 6 to the x back, and don't I get a natural log? Does that go in the numerator now, or does that go in the denominator? It goes in the denominator, and it's a natural log of what? Of 6. If you were taking the derivative of 6 to the x, what would that equal? 6 to the x times what? Natural log of 6. Bless you. All right, the next one. Well, I don't want you to look up there. What is antiderivative of the natural log, or of tangent is a what?
Natural log.
It's the natural log of the absolute value of cosine of what? 10x. Okay, I want you to be careful. Is there a negative out front normally? Yes, but since there already was, it's going to be what? Positive. Is there anything else out front? 1/10. Why is there a 1/10? Chain rule. Okay. The other one we probably don't remember very well is the antiderivative of the secant, which also involves a natural log. Do we remember what that one is? That would be the natural log of the secant of 4x plus what? Do you remember? Tangent of 4x. What has to be out front? 1/4. So if we don't remember this one, we got to make sure we now what? Do? You're all happy about that.
Is it a negative natural log?
Nope. This one is a positive.
So would it be negative?
I'm sorry?
Is
No.
it double negative, or is it?
Where? For this one?
Oh, I was
That was, so this was the first one. That's the second one. Okay. What function has the derivative of secant tangent now? Secant of 8x, right? So that would be plus the secant of 8x, but what has to be out front? 1/8. But wait, is it positive in front or a negative? It was a negative. Plus some what? Constant. See, these are the 3 I know we're not good with, right? Okay, and that's why I wanted to make sure we hit those. I was not expecting mastery on those. Okay, and as a result, if you look down at 22, do you see a secant and a tangent again? Okay, so let's look at this one. Let's look at the first one. What is that one? Antiderivative. Natural log. So it's 4 what? Not just x. Absolute value of x. We've got to make sure we know that one. Okay, sine of 12x. When I take the antiderivative of it, it's going to be a what? It's going to be a cosine of 12x, right? I know I need a 1/12 out front. Is it positive out front or a negative? It's positive. I only know derivatives. When I take a derivative of a cofunction, I always get a what? Negative. Okay? That's secant. Okay? Where? Yes, thank you. Thank you. Okay, based on what we did up top for the secant, you know, I'm going to ignore the 3 till the end. We'd have a natural log of what? secant of what? 5x plus what? Tangent of 5x. Okay, now what's out front? I already had a negative 3, but there's one other thing that joins it. What is it? The 5. Okay? And why is it a negative? Because it already was what? Negative. Okay, and I drew the tangent. Normally, it becomes a negative, so what's it going to become in this case? A what? Positive. So it's going to be a positive natural log of the absolute value of what? Cosine of what? Kx. What's out front? 1 over k. I'll move that up a little bit. Okay. And then the other two boogers. One of them is an arctan, one of them is an arcsine. Do you know which one is the arctangent? The first one is, right? So it's 10 over 1, because there's a 1 over a out front. Arctan of what? Of x, or not arctax, although I have to do my taxes. Of x over 1. Anything else? Anything else? No. What's the next one? Last one. So it's 10 over, there's no 1 over a out front. Arc sine of what? X over 1. Now it's plus what? C. Okay. So we got to get, now we're pretty comfortable with this one. We're comfortable with this one. Here's where we need to get stronger on, right? That's why I'm putting those in. Okay. Now, if this had been a 9, how would that have changed the arctangent? This would be over what? 3 and over what? 3. If this had been a 9 here, this would have still been what? 10, and this would have been x over what? 3. Okay? All right. So we got 2 to go. Is it just these 2? Yeah. All right. Can you tell me without doing any work, is that going to be a finite number, or was that converge or diverge? Why? P is bigger than 1. So we're getting the feel for them. The question is, can you compute it, right? Okay. So we're going to do the limit as b goes to infinity of 5 to b. Why can I not use my formula? The lower limit's 5. Thank you. And I'm going to write it as 3x to the negative 4 dx because I'm much more comfortable with that. You may be able to do it in your head better than I, but I can't. All right. So what does that become? X to the what power? X to the negative third. What is out front now? 3 over negative 3. I'm going to leave. You're right. It's just a negative. I'm going to make sure I cover myself here. From 5 to b. So it's the limit as b goes to infinity. And yes, now it's negative 1. And it's now going to be what? 1 over b cubed minus 1 over what? What's 5 to the third power in the bottom? Careful. 125. Make sense? So what does that equal? What number will that equal? As b goes to infinity is going to be 1 over what? 125. Does that make sense to everybody? Okay. All right. And our very last stinking one. Is that an arctan?